So if I should come to network, okay, so you can see time to live, all right? And there should be something that shows where like the server I am on or something. That was what I wanted to show. But it looks like the appearance is different. But let me just go to google.com. Correct. It lose plenty things. So here I should be able to see the server that I am connected to. All right. Probably I've forgotten where to look at or something. But I should be able to see the server that I am connected to and the the sticky session, right? The session that I'm on and the time that it is going to expire, right? All these things are there. You are able to see it in your browser actually. You are able to have that information in your browser. So what it does is that if I visit a website, okay, and for example, I open this, okay, so I search for something and then I open the first result. The next time I go to Google, so even though, let me even close this tab, right? And then I go to Google again and then search for this, right? The results that will come, it will include this same one that I visited, but you can see that it shows that what I've clicked on it already, right? So sticky sessions, or there's another word also called session affinity, right? It helps you to keep your sessions or route your traffic to the same server that you connected to. All right. So a user here there is a load balancer between you and then the application. All right. So user 1, 2, 3. All right. So if user 1 sends a request here, and then the load balancer takes the user here, the next time that the user will send a request, the load balancer is smart enough to know that, okay, this is the same person. So it sends you to the same server. All right. And then this user might send here, and then the next one will be sent here. This user request to be sent here, and like that. All right. But yes, there is also what the time to live or the session timer. So if I set it to 1 day, it means that after 24 hours or after 1 day, all this will be cleared. Okay, all the information, all my session will be cleared. So the next time that I'll visit Google, I will not, and then I put in the search, I might not have the same results, right? The same result that I had earlier. Okay, I might not have the same result. The results might change, right? Even probably the order or the sources that I'm given would also change, right? But that is just a session affinity. It's just to save your session, all right? And there is also a concept called cross-zone load balancing, all right? So uh, cross zone load balance, right? So this one will evenly distribute load across AZs, right? Now, what this means is that supposing you have EC2 here, you have another one here, you have another one here, right? You have 3 EC2 instances here. And then you have, so this is AZ. So AZ1 and then AZ2, okay? And then you have load balancer 1, load balancer 2, because we want our load balancer to be highly available, okay? So you have 3 instances here, and then you have 7. So let's say you have a total of what, 10 EC2 instances, okay? Now, with cross-zone load balancing, so usually when a user is sending traffic here, 50% of the traffic comes here, 50% of the traffic also what comes to this AZ, right? With cross load balancing, the load balancers, or I mean, it's smart to know that, okay, we have a total of 10. So let's distribute the traffic. So it will evenly distribute the traffic 10%, 10%, 10% across. So in total, we have what? 100 load balance, sorry, 100% load balancing, right? Each one is receiving 10, 10, 10, 10, 10. But if cross-zone load balancing is disabled, then the 50% traffic that is coming to AZ1 will be shared evenly just among the 3 instances, all right? So a quick calculation, 50% divided by 3 is how much? Somebody should give me an answer. 50 divided by 3.
16.666.
Yeah, so let's say it will just distribute 17%, 17%, 17% here, all right? And then the 50% will also be distributed across what? These 7 instances, all right? So that will also be 50% divided by 7. And then we might have around like 7.1 or 7. So 7% of the traffic will also be distributed here, right? So that is cross-zone load balancing. Okay. Please, is that clear? If anybody has a question, kindly ask. Okay, so we move. Now with a cross zone for ALB, so it's enabled default, right? It's enabled by default in ALB, and then there is no charge for cross zone load balancing. Right, so there's no charge for interzone. Let me do it that way. Right, so if a load is balanced across the 2 zones, there is no charge. That is only that's for ALB, all right? And then in a classic load balancer, even though it's deprecated, but classic load balancer and NLB are disabled by default. However, there is interzone, right? LB charge in NLB, and then there is no interzone charge in CLB. Okay, so it is disabled by default in classic load balancer and then NLB, but enabled by default in ALB with a charge only NLB that is charged, but for ALB and CLB, there is no charge. Okay. And we've spoken about ACM, how we can use certificates to encrypt our traffic, right? How we can install. So we install a SSL certificate on the load balancer. So what you do is that you enable an HTTPS listener. So you know the listeners that normally we have been using on the load balancer is HTTP. But if you add an HTTPS listener, then it means that you want to use SSL. So you have to load that certificate. You can either use ACM or you can import the SSL certificate. Currently, the name is a TLS certificate, right? Transport Layer Security, but still people call it SSL. So the certificate can come from any SSL provider. You know, there's Commodore, there is Let's Encrypt, Symantec, GoDaddy, the SSL store. These are all SSL stores. So you import your certificate, your SSL certificate, right? And then onto the listener, right? And anytime a user makes the HTTPS request, then the load balancer will load what we call X509 certificate, right? And that is also called certificate termination. So anytime you hear certificate, so the word termination, right? The word termination itself in IT means a lot of things, right? One in one usage, termination means that you are like closing or canceling or those things, the connection. And then in another vein, terminating means that you're actually like initiating a connection. Okay, so we have to also get notice this. So we have something called certificate termination. All right. So what happens is that if a user, I will represent it with you, right? A user makes an HTTPS request. All right. So what the load balancer will do is that, so you have your certificate. All right. You have your certificates. So X509, right? Certificate here. So what the load balancer will do is that it will just load the load balancer. All right. And then now, the load balancers communicate with the EC2 instances via HTTP. All right. So it will load the certificate and then now will communicate via HTTP to the EC2. So always the connection here is, the communication from here to the load balancer is encrypted. All right. And then this one will use, probably there will be a decryption here, and then we'll communicate to the EC2 via HTTP. All right. So your certificate, as we learned in certificate manager, you can manage it with ACM. All right. Is there any question? There is another concept called server name indication. All right. And then what happens is that this enables you to load multiple SSL certificates, right, onto your load balancer. All right. And this only works for the ALB, NLB, and CloudFront. Okay. So server name indication is just helping you to load multiple SSL certificates. All right. And this means that you might have multiple applications. Okay. So the same thing, you have application 1, you have application 2, you have application 3. All right. And then you have certificates, so C1, C2, C3. Right. You have your load balancer here. Now the user makes a request. So for example, for containerized applications, right? So this can be, maybe this one is hosting your users. All right. This one is hosting, let's say, hosts. Okay. And then let's say this one will also host the reels. All right. So we are looking at a typical social media application. They all have different SSL certificates. You load it. So you load it into your load balancer. Okay. So if a user, let's say, visits a link like, let's say, app, right, slash users. Now, based on this query string, right, the load balancer will know the right certificates to load. So maybe the certificate will be this one, all right, and then it will communicate, and then now it takes you to the users. All right, so you are able to load multiple SSL certificates into the load balancer, and then each of them, per the request, the load balancer is smart enough to know the kind of, right, the certificates to um, pick, okay, and then route the traffic to the right application. So that is the server name indication, okay. So that is also one thing about load balancers. One last thing about load balancers, then we'll go to the next one, is something we call connection draining, right? Now, connection draining is when you have connection draining is when you have, so these same applications, okay? Now, one application becomes faulty. So let's say the EC2 instance here becomes faulty. All right. Normally, immediately becomes faulty when connection draining is not active. Immediately becomes faulty. All existing connection will also be terminated. All right. All existing connections will be closed or prevented. But connection draining makes it possible that, okay, this one is faulty, but then there are still connections that are going through it. So let's give enough time, right? Let's give ample time for these connections to get done. Then after that, then we close the connection. All right. So that is what we call connection draining. So even though the instance is not available, but current connections or existing connections are allowed to complete, okay? And then now traffic stopped being routed or balanced to that, okay? So there are some sites that even though the site goes down, there is no way you are going to see an error message, or you'll be directed to an error page, okay? The next time that you refresh, it will send you to another server, right? So that is what we call connection draining. Or there's no way you'll be on the site and it will be like 404 cannot be found, or 502 bad gateway or something. Okay, so that is connection draining. It's the same concept that I was trying to explain when we were doing the VPC discussion, right? That with security groups, when you allow ICMP and then you initiate an ICMP communication, that is, you do a ping, immediately the connection starts. Even when you remove the rule, it will still not terminate at the spot. What happens is that it will allow the current communication to still happen, but immediately the communication is exited or closed, then you cannot, initiate another ICMP communication between the two resources or the two systems, right? So that was the same concept that I was trying to use to explain the security boosting. So that is it with connection draining as far as load balancers are concerned. Okay. So that would be it on load balancing. If anybody has a question, then we can bring it up. Then I try my best to answer. If not, we will move to FSX. So FSX, I don't know the full meaning, so let's all look at it. It could probably be file system accelerated or something. What is the full of FSX? No. Yes, it could be a accelerated file system or something. FSX stands for Amazon FSX. I want the full meaning. Anyway, we don't have the full meaning. Probably it's just that is just what.
Maybe file service exchange or something.
Well, it could also be. Yeah. Yes, because if you look at here, file systems, backups, file shares. So it could, yes, it could be exchange. Okay. So FSX, like in its self, right, is a file service system. And what happens is that it helps you launch third-party high-performance file system on AWS, right, as a fully managed services. So just like you use RDS, okay, to do what? To host your database, right? To host database. Just like you moving your database to RDS. If you have a file system, so file system is, it could be a directory that you have your, let's say, Active Directory users, you know, all those things in there. You use it to do your data processing and then all that. It's just like that. So it's like you move your on-prem file service onto AWS as a fully managed service. So just like RDS, you move your database from on-prem onto AWS as what? As a managed service. All right. So if you hear anything like third party high performance file system, right? Then you are looking at what? FSX. All right. Now there are different services. Right? There are different FSX offerings. FSX for Lasta, FSS for Lasta, FSS for Windows, FSS for NetApp on Tap, FSS for OpenZFS, right? So for NetApp on Tap and then OpenZFS, honestly, I'm not actually like going to talk a lot about it because all those ones here, the exams will tell you ZFS file system. You get it. You want something, a managed ZFS file system. NetApp on Tap, the same thing. Managed NetApp file system or NetApp on Tap file system. You are definitely going to see that, right? But I will also try and if there is any other thing, I'll talk about it. But let me just start from the top. So FSS for Lasta is derived from the word Linux and cluster, right? That's where the word Lasta was derived from. So Linux and then cluster, right? And then we had FSS for Lasta. So most of it, so Lasta in itself is for high performance computing, right? So HPC, high performance computing. And then when we talk about high performance computing, then definitely machine learning will be there, all right? Machine learning, video processing, you can have financial modeling, design automation, right? Mostly design automation. Electronic, right? Electronic design, the design automation. And there are two storage options. You can either go for SSD or HDD. And then obviously SSD is more expensive than what um HDD. All right. But for SSD, if you want, let me do it this way. So for SSD, you want low latency, and then IOPS, right? IOPS intensive workloads, and you want there's one, I forgot it. IOPS intensive workloads, and there is something file operation. You want small and random file operations, right? And then the HDD is for throughput, intensive workloads and large sequential file operations, right? Right. So these are the storage options for FSX for Lustre, right? And then obviously it's for Linux. So let me just do right for Linux systems. Okay. But most of the times, machine learning, video processing, high performance computing. Anytime you hear high performance computing, then you are looking at FSX for Lustre. And it also has a seamless integration, right, with S3. What this means is that you can read S3 as a file system, right, from FSX, and then you can also write, right, from FSX to S3. Okay, so it also has, so if you hear anything that has seamless integration with S3, then you are also looking at FSX for Lustre, right? It has two deployment options. We have I think Scratch, and then so deployment option. This autocorrect thing. So deployment options, there is Scratch. That's for temporal, right? So you want it to like for a quick, work, especially for these processing jobs and then all that. So you want a very temporal storage, right? Please don't confuse this for instant store, right? Instant store has a different usage. Okay, right. So this is like a temporal, and then there is no data replication option here, and then there is the persistent, right? As the name goes, right? Persistent is for long-term storage, And then you also have so long term, and there is replication in the same availability zone. All right, so the data is being replicated on another, let's say, cluster, right? Another FSX for Lustre cluster or node in the same availability zone, right? And you are able to also optionally, as you said, you can integrate it with S3. All right, you can also integrate it with S3. So that is it for Lustre. Now for Windows, obviously, as the name says, it's for Windows, but then it can also be mounted on, right? Can also be mounted on a Linux system, right? But it's mainly for Windows. And that one, if you also hear SMB, right? It uses the SMB protocol, and then Windows so supports SMB and Windows NTFS. Okay, so can be mounted on Linux EC2 instances. Yeah. Okay. And support. So anytime you see SMB and Windows NTFS, then you are, and then most of the times you will see SMB alone, right? Then you are also looking at FSX for Windows. All right. And another thing. So I think I spoke about this already. It's can be integrated with Microsoft Active Directory. Okay. You can also use ACLs, right? Access control lists on that as well. And then you can also use it to group multiple file systems, right? Through what you call Microsoft distributed file systems, right? And then you can join it with the FSS. So this is a high level overview that I'm giving you, but the sysadmins and then the network admins, this is mostly on the network level, right? The sysadmins and then the network admins knows what it is. You can have different file systems on-prem. So you use what we call the Microsoft distributed file systems to group these file systems together, and then you can use it to join the FSX for Windows as well. All right. For access, I didn't talk about access for Lustre, but they run through all of them. You can access it through VPN, right? Hey, today my typing is through VPN or direct connect. Okay, you can access it through VPN or direct connect, and the data is also backed up daily to S3. All right, and you can also configure it to be multi-easy. Right, you can also configure it to be multi-easy, right? So all these stuff can also be for FSX for Lustre. All right, so that is for the access. So you can access it via VPN or easy. And let's see how they can scale up. Did I say FSS for Lasta can scale up and down based on the storage. I don't think I mentioned that. All right, but most of them they can scale to the IOPS. The two of them, Lasta and then Windows, have the same IOPS. They scale up to like about 10 gigabytes per second. There's millions of IOPS, and it can also store 100 petabytes of data. I think it's the same thing with Lasta. All right, wait, please let me check something here. So for Lasta, okay, so for Lasta, it can scale up to 100, yes, GB per second, right? Files for Windows scale up to 10 gigabytes per second, right? Yeah. So tens of gigabytes per second. For the IOPS, they are the same. So millions of IOPS, and then yes, they all have millions of IOPS. Right? So millions of IOPS. But Lasta has what we call sub millisecond latency. All right, so sub ms latency. So definitely it's a little bit faster, right, than FSX for Windows. Right, so that's basically the difference between them. Let me see if I missed something. I'm checking my notes. And so I talked about the fact that for Windows, data is backed up to S3 for disaster recovery, right? So for PR, all right. Okay, so we come to NetApp on tap, right? So as I said, for NetApp on tap, it's just simple. The exam is going to ask, they want a file system for a managed net app on tap. All right. And then the protocol is NFS, SMB, and iSCSI. Okay. You don't have to like know into detail what this is, but all you need to know is that these are the protocols that they support. Okay. So as I said, if you want to move workloads on tap, there's another one called NAS. So if you don't see on tap and then you see NAS, it's the same thing. Myself, I don't know what NAS is, right? To AWS. So you move your workload on tap or NAS to AWS. And this one has a lot of operating systems that it's compatible with. It's compatible with Linux, compatible with Windows operating system, Mac OS. It can also compatible with ECS, EKS, and then EC2 itself. All right. This one has an auto scale capability. So depending on your storage, it can scale up and then also shrink in, right? When there is what's it called? There is less utilization. Okay. There is also a snapshot feature and replication. Okay. There's something we call compression, so data compression and deduplication. So deduplication is like data is replicated, right, to a location, right, you are able to, or is duplicated to a location, you are able to duplicate that duplicated data. Okay, that is just what it means. And then there is also what we call points in time, right? Instantaneous. Cloning, right? So it means that you are able to, so if you have a workload that you would want to test, you are able to clone, right? You are able to clone certain part of the data, like at a point in time, maybe, for example, let's say 1 minute ago, you want to just clone your data or your workload that was loaded or that was processed maybe 2 minutes, 1 minute, 5 minutes ago, right? You can also do that. All right. So it has that feature. And we come to Open FSX for Open ZFS. So for Open ZFS, the same thing. It's a managed ZFS file system. And then this one supports only one file system, and that is, so supports only ZFS. Okay. And this one can actually scale up to 1 million IOPS, right? Input and output operation per second, and it's has like very low latency, right? So do I put ultra low latency, right? That is just about less than 0.5 millisecond. Okay. But this one doesn't have, so this one is no deduplication. Okay. And this one also has what? The point in time instantaneous cloning as well. Okay. And then you are able to move workload on ZFS to AWS. All right. So that is just about the various file systems. So all you need to know is these keywords, right? So if you see they want to move a workload on ZFS to AWS, you even don't need all these parameters again. You don't need all these details again, right? But if they say, oh, they want a file system, NFS, they want a file system that supports only NFS and then can scale up to 1 million IOPS with ultra low latency or with less latency or latency, right? Less than, okay, let me even put this. So let me just do it this way, right? So latency less than 0.5 milliseconds and has point in time instantaneous cloning, then you are looking at what? FSX for OpenZFS. With FSX for net on tap, then you are looking at moving workloads from what? On tap or NAS, any of them, right, to AWS, and then supports the NFS, SMB, and iSCSI. So all of that, most of the time, you are looking at the, if it is not an intersection, it is what? Whatever lives outside the intersection, right? Because Windows also support what? SMB. But here there is what? iSCSI. All right. So these are the things that you have to also look out for, because you might see SMB, no, then your mind is heading towards FSX for Windows, right? But you have to also look at, right, on tap, and then you can see this one support a wide range of operating systems and also has what? Auto scale capability. There's a snapshot and a replication. It also supports compression and then deduplication. And the difference between the on tap, apart from the on tap workload on tap, this one doesn't support what? Deduplication. Okay. And for Windows, yes, you are looking at SMB and NTFS has integration with Microsoft Active Directory and then ACLs, right? And what? Okay, and can scale up to tens of gigabytes of data and then millions of IOPS. And then you're also looking at what? FSX for Windows, all right? So for Lastar, FSX for Lastar, you are looking at for a file system for Linux, right? And it's for high performance computing, machine learning, video. So they can say a video processing agency. Immediately you hear that, then you, depending on how the question progress, right? So a video processing agency needs a file system, right? For its probably IOPS intensive workloads or compute intensive workloads, throughput intensive workloads, right? And they need a file system that can scale up to 100 gigabytes per second and has millions of IOPS and has sub-millisecond latency. Then you are looking at what? FSX for Lastar, right? But if the question just goes like they need a third-party high-performance file system, then and you just have FSX in the option, then you are looking at that as well. Okay. So that's about it. Is there a question? Let me check the chat. Is there a question? If nobody has a question, is it a confusion or understanding? All right, so I'm actually like giving these pointers because at this point, and you're feeling like, you would want to go deeper, see how it works, even though, yes, I gave some little more details, but, it's important to just know your pointers to answer your exam questions, right? That's the best way, right? We will not do API gateway today. I wanted to add to it, but API gateway. Yes, it's a lot of information. I understand. But Miss Mission is my breast, my breast, because I could have just given the difference, layer 7. Oh, this one, let me just share it. The notes, let me just share it. Why? Session notes. Okay, so I'll do it view only so that nobody will just will go and change. So if you want to do your changes or if you want to do your changes, you can just make a copy. All right. So I've shared it in the chat. Okay. So key takeaway points for the load balancers. All right. So let's go into it. So key takeaways for the load balancers. One, the load balancers, I said we have the ALB, that is application load balancer, the NLB, all right, and then the gateway load balancer. There's a deprecated one called the classic load balancer, which we will not talk about it because the exam students like actually talk about it, right? So for the ALB, it's a layer 7, right? It works at layer 7, and then that is where HTTP and HTTPS works. So you are able to route to multiple machines, right? Multiple applications on a machine. So multiple applications, right, on a machine. Talk of something like containers. Okay, and then you use what we call the rule routing, and in rule routing there is packet or payload header, or using a query string or parameter, and then there is a redirect feature as well, right? It also supports, so this HTTP and an HTTP2, when you are setting up a load balancer, and I think when you are setting a listener, you are able to choose a listener or a target group, you're able to choose for either HTTP1 or HTTP2, but mostly we use the HTTP1, HTTP2, or WebSocket. So these are the protocols that it supports. And it also has low latency, 400 milliseconds, all right? And then the target groups, we looked at it, we know it can be EC2, other applications, or an auto scaling group, and also API gateway. And I said the load balancer gives you an endpoint DNS address, right? The load balancer endpoint. You don't have an IP address. So that's one difference. With network load balancer, your endpoint is what? A static IP address per AZ. Using the NLB is not free. Sorry, it's not included in the free tier, right? Both load balancers, you are paid for the traffic that are being routed, right? But ALB is included in the free tier. NLB is not. NLB works at what? The layer 4. And then that is where TCP and then UDP resides. It has less latency than the ALB because that is 100 milliseconds, right? That is like way a lot of difference. And if you hear millions of requests per second or high performance, then you are also looking at what? The NLB. But one peculiar thing about NLB questions is that you hear they want a static IP for the AZ. Then you are looking at what? A network load balancer. The target group of a network load balancer can be applications, it can be EC2, it can be an IP address, and it can also be an ALB, right? Another application load balancer. Gateway load balancer is mostly for security purposes. It works as layer 3, where we have the ICMP, you have the IP, we have the packets, like all those, anything that has to do with network packets, all right? And then you use it to manage a fleet of third-party virtual network appliances on AWS. So you are looking at routing traffic first to your firewall for a particular traffic or packets to be inspected. If it is approved for a pass-through, then it communicates back and then now routes you to the right resource, right, or the application. And then it provides what? A single entry and a single exit. And one keyword for gateway load balancer, if you see Geneva protocol on port 6081, right? You might not see this, but always make sure that you are seeing something like a third-party virtual networking systems, or they want to route traffic to their firewalls, and you are looking at what? The gateway load balancer, right? I explained the concept. I explained the concept of what? Cross-zone load balancing as well. That is evenly distributing load across AZs. So if you have two availability zones and you have traffic being routed to the availability zones, if you have cross-zone load balancing enabled, then traffic will be routed evenly or will distributed. Sorry, I keep using routing. Traffic will be distributed evenly to the instances, regardless of or irrespective of the number of instances in an availability zone. So if you have 10 EC2 instances spread across 2 availability zones, you have just 2 at availability zone A and then 8 at availability zone B, then with cross-zone load balancing, it is very smart to know that, okay, so we still have 10, right? So let me distribute 10%, 10%, 10% each to the EC2 instance. Okay, 10% each to the EC2 instance. But if cross-zone load balancing is not enabled, then the AZ with 2 instances will receive 25% of the traffic each because they are 2. And then the rest of the 50, it will be also be distributed. I think that will be like about 12% or so, right, across the AZ that has the 8 instances. Okay, and then I talked about the default features, right? So in ALB, cross-zone load balancing is by default enabled, whilst it is by default disabled in NLB, and then the classic load balancer However, interzone load balancing is free for the application load balancer, whilst it is charged in the interzone, sorry, it's charged in the network load balancer. All right, but there is no interzone charge for CLB if you intend to enable it. All right, and I talked about the concept of what server name indication. Just put it in your mind that anytime you hear load multiple SSL certificates into the load balancer, then you are looking at server name what indication. And then it only works for ALB and then the NLB and CloudFront. So you know CloudFront is also able to route traffic to a resource, right? So you can load ACM or sorry, SSL certificate or TLS certificate onto your CloudFront, ALB or NLB, right? And then it is just depending on the rules that you set per the URL that your user. Oh, MKS, you just came, right? Per the URL that the user is visiting, then the right certificate is what is loaded, and then now you are the load balancer is able to communicate via the protocol that it has to communicate, right? One thing I skipped is target. I mean, we now know target groups. I know I didn't skip that. Okay. So how it works is, I mean, it uses what we call certificate termination. So if you are visiting, depending on the URL you are visiting, it's able to load the right certificate called like X509 certificates, and then it does your connection for you, right? And I also explained connection draining in the sense that where you have a resource failing, you have an EC2 instance failing, but there is an existing connection that is going on, right? So what happens is that connection draining enables that communication to happen and then end. Then after it is ended, then it shuts the entry point to that resource, right? So it just it just prevents connections from being like current connection or existing connection being dropped when a resource fails. It waits for it to complete, right, the communication, and then now shuts the way to that resource till the resource is healthy again, and then traffic begins to be routed there, right? So that is also the key takeaways for the load balances, right? Any other question? You're welcome, Benji. Okay, so I'll stop the recording now if there is no more question. You're welcome, Mr. Isaac. I'll stop the recording now.